Hello everyone, and here's another video on the derivatives of algebraic function, and this time we shall talk about implicit differentiation. So implicit differentiation is a method used to find the derivative of an implicit function of the form f of xy equals 0. An implicit function is a function whose dependent and independent variable are mixed up. For example, x squared plus y squared equals 9 is an implicit function. 3x squared y plus 4xy squared minus 2xy equals 4 is also an implicit function because, as you can notice, the variable x and y are mixed up. For the function dy dx, we know that the y is the dependent variable and x is the independent variable. So you will notice that the variable on the numerator is called the dependent variable, and the variable on the denominator is an independent variable. For instance, if we have dw dz, we know that w is the dependent variable and z is the independent variable. And in implicit differentiation, we have to take note of two things. Number one, we shall differentiate the function f of xy equals 0 with respect to the independent variable, and differentiate f of xy equals 0 with respect to the dependent variable. But when differentiating with respect to the dependent variable, you affix the variable of differentiation or the operator dy dx. Okay? So when you are differentiating with respect to y, we will be holding all other variable constant. For instance, if we wish to differentiate say 3x squared y in terms of y, then we say it's 3x squared. We will be holding 3x squared constant, and we shall only differentiate y, which is equal to 1. Similarly, if we wish to differentiate the same function with respect to x, so y will be held constant, so you just copy 3y, and then you differentiate x squared, and that is equal to 2x. So you'll have 6xy being the derivative of 3x squared y in terms of x. Okay. Similarly, if you have x squared, okay, and you wish to differentiate it with respect to y, you say it's 0 since there is no variable y here. And the derivative of x squared in terms of x is in fact equal to 2x. And these are the things that you need to remember in employing implicit differentiation. Okay, let's have some example, I think. Yeah, okay. If we wish to find dy dx, if 3x to the 4y squared minus 7xy cubed equals 4 minus 8y, so what are we going to do is we will differentiate this group, okay, in terms of x, and then differentiate it again in terms of y. So you differentiating this in terms of x, so you have this, plus you do the same in terms of y, equals. You differentiate this in terms of x, and then differentiate it again in terms of y, okay? And then differentiating 3x to the 4y squared minus 7xy cubed in terms of x, so we shall have 12x cubed y squared minus 7y cubed. So here, we shall treat 3 and y squared constant, okay? And then you differentiate x to the 4, and the derivative of which is 4x cubed. And then we shall have 12x cubed y squared. And the derivative of 7xy cubed in terms of x, okay? So that's 7xy cubed. So you just copy 7y cubed, and then you differentiate x, which is equal to 1. And then, so we shall have 12x cubed y squared minus 7y cubed. For instance, if we are differentiating 3x to the 4y squared minus 7xy cubed in terms of y, since y is the dependent variable, and then you shall affix dy dx. Okay? So dy dx times the derivative of 3x to the 4 in terms of y. Okay? And then you just copy 3x to the 4, and then differentiate y squared, and that is 2y. So we shall have 6x to the 4y. Okay, and then for 7xy cubes, so you copy negative 7x times, you differentiate y cubed, which is 3y squared. So you shall have negative 21x y squared. Okay, and then on the right side, since there's no x here, the derivative of 4 minus 8y in terms of x is 0, And then for the derivative of 4 minus 8y in terms of y, so you shall have negative 8 dy dx. And then the next thing to do is to collect all the terms containing dy dx. Okay, so we shall have 6x to the 4 y minus 21xy squared, and then you throw this on the other side, so that will become positive 8. And then these two terms will be transposed on the right side, sorry, and we shall have 7y cubed minus 12x cubed y squared. So the next thing to do is to divide everything by 6x to the 4y minus 21xy squared plus 8. So finally, dy dx is equal to 7y cubed minus 12x cubed y squared all over 6x to the 4y minus 21xy squared plus 8. Okay, so we shall have another example. And let's find dy dx if x squared y squared equals x squared plus y squared. Then doing the same, so we shall differentiate x squared plus y squared in terms of x, and then we shall differentiate it again in terms of y, and then equals the derivative of x squared plus y squared in terms of x, and then we shall differentiate it again with respect to y. Okay, so differentiating x squared plus x squared y squared in terms of x, we shall copy y squared because that is treated as constant, and then you differentiate x squared, and that is equal to 2x. So we shall have 2xy squared, and then the derivative of x squared y squared in terms of y, you copy x squared. So since this is treated constant, and you differentiate y squared. So that is 2y, and then you affix dy dx. So we have dy dx times 2x squared y. And then on the right side, the derivative of x squared plus y squared is 2x plus 0, since there's no x here. And then the derivative of x squared plus y squared in terms of y, so this will become 0, and then you differentiate y squared, and that is dy dx times 2y. And then again, we isolate all the terms containing dy dx, leaving us with 2x squared y. Then you throw this on the left side, so that's minus 2y, and then equals 2x, and then you throw this on the other side, and that will become negative 2x y squared. And then the next thing to do is to put this on the denominator. Okay, we divide everything by 2x squared y minus 2y, and that leads us to 2x minus 2xy squared all over 2x squared y, okay, minus 2y. And then I think we can cancel out something here. So we factor out 2x on the numerator, and I think 2y on the denominator, leaving us with, so you can now graph this off, and then dy dx equals x times the quantity 1 minus y squared, yeah, all over y times the quantity x squared minus 1. And then another example, say we wish to find the second derivative of y in terms of x if 4x squared plus 9y squared equals 36. Okay, yeah, okay. So doing the same, we shall differentiate 4x squared plus 9y squared in terms of x, and then we do it again in terms of y, yeah. And then you differentiate 36 in terms of x, or you differentiate 36 with respect to y, and you know that the derivative of this is 0, and this is also equal to 0. And then differentiating 4x squared plus 9y squared, so you'll have 8x, okay, plus 0 because there's no x here. And then for dy dx, okay, for the derivative of 4x squared plus 9y squared in terms of y, we shall affix dy dx, and then the derivative of this is 0 since there's no y here, and then the derivative of 9y squared is 18y. And then on the right side, you shall have 0. And then isolating dy dx, we shall have negative 8x. You throw this on the other side, and then you bring this on the denominator. So dy dx is negative 8x over 18y. And by getting the lowest term, that's negative 4x. Oh, yeah, okay. LCD is 2. Yeah, yeah. Okay, negative 4x all over 9y. So to get the second derivative, we shall differentiate dy dx. So since the derivative of dy dx, is equal to the second derivative of y in terms of x, and then we shall differentiate negative 4x over 9y implicitly. And so we have the derivative of negative 4x all over 9y in terms of x, and negative 4x plus all over 9y in terms of y. Okay, so to differentiate, okay, since negative 4 over 9y is constant, and then the derivative of x is 1, and then we shall only have negative 4 all over 9y. And since negative 4x all over 9y, we are differentiating it with respect to y, I can write it of the form 4x all over 9 times y raised to negative 1. And since this is constant, okay, so negative 4x over 9, we shall only differentiate y raised to negative 1, and that's negative 1, okay, y raised to negative 2. Or that is equal to negative, negative, so positive 4x all over 9y squared. And this is the derivative of negative 4x over 9y with respect to y. And we shall affix dy dx. Okay, so that's positive 4x all over 9y squared. Since we have here dy dx, we shall now replace dy dx by negative 4x over 9y. Okay, and then to simplify, so that's negative 4 over 9y plus dy dx is being replaced by negative 4x over 9y times 4x over 9y. Simplifying this algebraically, okay, so we shall have negative 4 over 9y. So negative 4x times 4x is negative 16x squared all over 9y times 9y squared is 81y cubed. Okay, so we shall have negative 4 over 9y minus 16x squared all over 81y cubed. And then writing this as one fraction, we get the LCD, which is 81y cubed. So 81y cubed divided by 9y is 9y squared times negative 4 will give us negative 36y squared. And then 81y cubed divided by 81y cubed is 1 times 16x squared is negative 16x squared. So we shall have 36y squared minus 16x squared. And then simplifying this, I shall factor out negative 4, I think, yeah. Factoring out negative 4, and then you shall have 9y squared plus 4x squared all over 81y cubed. And you take note that 4x squared plus 9y squared equals 36. So I shall replace 9y squared plus 4x squared, by 36, leaving me with negative 4 times 36 all over 81y cubed. And finally, the second derivative of y in terms of x is negative 16 all over 9y cubed. Okay, so let's have another example. Oh, yeah. Okay, so to simplify the technique of implicit differentiation, I'd like you to share this principle that if f of xy equals 0, then dy dx is equal to the negative derivative of f in terms of x all over derivative of f in terms of y. And that is the principle we are applying from our previous examples. Okay, we have example number 4. We use this principle if we want to get the derivative of dy of y in terms of x for 2x cubed y plus 3xy cubed minus 4 equals x squared y squared minus 3xy. So the idea is you need to settle the right side, or you need to rewrite the function such that the right side is equal to 0. So we shall throw this out on the left side, leaving us with 2x cubed y plus 3xy cubed, then minus x squared y squared plus 3xy, then minus 4 equals 0. So we can now rewrite this as f of xy equals 2x cubed y plus 3xy cubed minus x squared y squared plus 3xy minus 4. And then we can now use this technique, okay? So we have dy dx is equal to the derivative of this function, negative derivative of 2x cubed y plus 3xy cubed minus x squared y squared plus 3xy minus 4 all over derivative of this same function with respect to y. So differentiating, we shall have negative times the quantity differentiating 2x cubed y in terms of x, so that is 3 times 2, that's 6 x squared, and then you copy y. In terms of x, so these two are treated constant, so you copy 3y cubed, then derivative of x is 1. And then differentiating this with respect to x, y squared is constant, you copy it out, okay? And then differentiate x squared, which is 2x. So that's negative 2x y squared. And then the derivative of 3xy in terms of x is 3y. On the denominator, we shall differentiate the same function with respect to y. So 2x cubed will be treated constant, and we shall only differentiate y square, or y, sorry. And then we shall have 2x cubed. Okay, then plus the derivative of 3xy cubed in terms of y. So that's 3 times 3, that's 9. Then copy x and then y squared. Minus in terms of y, so that's copy x squared and then differentiate y squared. And that is negative 2y. And then derivative of 3xy in terms of y is 3x. So we have dy dx equals, you can just only introduce negative 1 each term inside the parenthesis, okay? So you shall have negative 6x squared y, then this will become minus 3y cubed, this will become plus 2xy squared, then minus 3y, all over 2x cubed plus 9xy squared minus 2x squared y plus 3x, okay? And let's have another one. Again, we wish to find the second derivative of y in terms of x if the square root of x plus the square root of y equals 4. If we want to use the principle or the theorem, so we shall rewrite this of the form f of xy equals 0. So transposing this on the left side, so you shall have x raised to 1 half plus y raised to 1 half minus 4 equals 0. And then we can now rewrite it of the form f of xy equals x raised to 1 half plus y raised to 1 half minus 4. And then we can now use this principle that dy dx equals negative df dx all over df dy. Okay? And then we shall have derivative of f in terms of x is, bring this down. So that's 1 half. Okay? X. Then you subtract 1 from 1 half, and that's negative 1 half. And then you affix minus sign in front. Okay? And then the derivative of this is 0, and the derivative of negative 4 is also 0 when we are differentiating it with respect to x. Okay? So with respect to y, so the derivative of x raised to 1 half is 0. The derivative of negative 4 is 0. So we shall only differentiate y raised to 1 half, and that is 1 half y raised to negative 1 half. And then we can cancel this out. So finally, we shall only have, okay, y raised to 1 half all over x raised to 1 half times negative 1. And this is our dy dx. All right, to find the second derivative of y in terms of x, we shall differentiate dy dx, and that will give us, okay, the second derivative of y in terms of x equals the derivative of negative y raised to 1 half all over x raised to 1 half with respect to x plus derivative of negative y raised to 1 half all over x raised to 1 half with respect to y. And differentiating this with respect to x, okay, so I can rewrite this of this form. Negative y raised to 1 half times x raised to negative 1 half. And since I am differentiating with respect to x, then I'll be treating this constant. Okay, so I'll have negative y raised to 1 half times the derivative of x raised to negative 1 half is negative 1 half x raised to negative 3 halves. Or this is equal to y raised to 1 half all over 2 x, and then this will become positive 3 halves. So that's y raised to 1 half all over 2x raised to 3 halves. And then we shall have, okay, that's y raised to 1 half all over 2x raised to 3 halves. And since we are now differentiating it with respect to y, okay, x raised to 1 half is constant, then I'll just have negative 1 over x raised to 1 half, then I will just differentiate this y raised to 1 half. So that's 1 half y raised to negative 1 half. Okay, so you shall have, yeah, negative y raised to negative 1 half all over 2x raised to 1 half. And then the next step is to replace dy dx in terms of this. Negative y raised to 1 half all over x raised to 1 half. So we shall have, okay, just copy this first term. And then dy dx is being replaced by negative y raised to 1 half all over x raised to 1 half times negative y raised to negative 1 half all over 2x raised to 1 half. And then simplifying this two, so you just copy the first term again. So negative will give us positive y raised to 1 half. And then this is y raised to negative 1 half. So 1 half minus 1 half is equal to 0. So that is y raised to 0 and that is equal to 1. And then on the denominator, we shall have 2 x raised to 1 half times x raised to 1 half is simply x. So we only have 1 over 2x for the second term. And then we shall now get the LCD here. So the LCD is 2x raised to 3 halves. So 2x raised to 3 halves divided by 2x raised to 3 halves times y raised to 1 half is y raised to 1 half. Yeah, plus then 2x raised to 3 halves divided by 2x is x raised to 1 half times 1 is simply x raised to 1 half. Okay, that's it. Okay, and then since y raised to 1 half equals square root of y plus the square root of x all over 2x raised to 3 halves. And then from our given, square root of x plus square root of y is equal to 4. So I can now replace this by 4. And we shall have 4 all over 2x raised to 3 halves. And then we can now get the lowest term of this fraction. So that's 4 over 2. And that is 2 all over x raised to 3 halves. And